Welcome to the DIY Honda Garage channel. DTC P2121 pertains to the APP sensor A, specifically referred to as TP sensor D, which indicates that there is an issue with the accelerator pedal position sensor's performance or output. This code is triggered when the sensor's readings are outside the expected range, which can impede the vehicle's acceleration and overall performance. The APP sensor is located at the accelerator pedal assembly, detecting how much the pedal is pressed and sending that information to the engine control module, ECM, to adjust engine parameters for throttle control. Proper operation of the APP sensor is crucial for vehicle responsiveness, fuel efficiency, and safety. When this error code is present, it signifies either a malfunction within the sensor itself, an issue with the wiring leading to the sensor, or a potential problem with the ECM interpreting the data. Hence, troubleshooting the P2121 code is essential to ensure that the vehicle performs efficiently and safely. DTC P2121 specifically indicates an issue with the APP sensor A, also known as TP sensor D, which is crucial in monitoring the position of the accelerator pedal. This sensor is an integral part of the accelerator pedal assembly, located in the driver's footwell area. Its primary role is to transmit real-time data about the pedal's position to the engine control module, ECM, which in turn adjusts the throttle opening for optimal engine performance. When the APP sensor experiences a malfunction, the readings can fall outside of the expected voltage range, leading to reduced engine responsiveness or a potential limp mode scenario. The communication between the APP sensor and the ECM is vital for proper vehicle operation. If the DTC is triggered, it indicates the system is not functioning correctly and requires immediate troubleshooting to prevent further performance issues. Several factors can lead to the triggering of DTC P2121. One possibility is a faulty APP sensor itself, which may have internal issues preventing accurate voltage readings from being sent to the ECM. Another common cause is shorted wiring or damaged connectors leading to the APP sensor. This can result in either incorrect signals being sent or the sensor being unable to send signals altogether. Open circuits in the wires connecting the APP sensor to the powertrain control module, PCM, could occur due to wear or damage, further complicating the situation. Lastly, a failure within the PCM itself could result in misinterpretation of the sensor data, leading to this error code being registered. Identifying the specific cause is crucial for proper repair and to avoid unnecessary component replacements. When DTC P2121 is active, drivers may notice several symptoms that indicate a performance issue. One of the most prominent signs is poor engine acceleration. The vehicle may struggle to respond to the accelerator pedal input. Reduced throttle response can also occur, leading to a feeling of sluggishness or lack of power when attempting to accelerate. Moreover, warning lights may illuminate on the dashboard, indicating that the vehicle's onboard diagnostics have detected an issue that requires attention. In some cases, the vehicle could enter a limp mode to prevent further damage, limiting speed and power output to allow the driver to navigate safely until repairs can be made. It's essential for drivers to recognize these symptoms, as they indicate that immediate action may be necessary to diagnose and fix the underlying problem. The first step in troubleshooting DTC P2121 involves verifying the issue and checking vehicle status. Begin by turning the vehicle to the on mode without starting the engine. Using the Honda Diagnostic System, HDS, clear the DTC to reset the system. After clearing the code, it is crucial to wait for approximately 10 seconds to allow the vehicle's systems to recalibrate. Subsequently, check for any pending or confirmed DTCs once again. This will help determine whether the P2121 error is consistent or if it was an intermittent issue. If the DTC reappears, it indicates that the failure is confirmed, and you should proceed to the next step in the troubleshooting process. If the code does not return, it could suggest that the issue was temporary or might be related to connections or wiring. For the second troubleshooting step, begin by turning the vehicle to the off lock mode to ensure safety and prevent any electrical mishaps. Disconnect the APP sensor 6P connector, which is essential for examining the sensor and its associated wiring. Once the connector is removed, turn the vehicle back to the on mode without starting the engine to check the voltage supply. Using a multimeter, measure the voltage between test points located at the female terminals of the APP sensor 6P connector. Test point 1 is terminal number 4, while test point 2 is terminal number 5. The expected voltage here should be approximately 5.0 V. If this reading is confirmed, you can move on to the next step, as the power supply to the sensor appears to be functioning correctly. However, if the voltage reading is significantly off, it indicates potential issues within the wiring or connector that requires further diagnosis. Step 3 involves checking for a short in the VCC4 wiring. Begin by turning the vehicle to the off lock mode for safety. Use the HDS to jump the SCS line, which stands for the SRS connector short, and wait for more than 1 minute to ensure proper system reset. Afterward, disconnect the PCM connector A, which is a critical part linking various sensors to the ECM. With this connector disconnected, check for continuity between the two test points. The first test point is again from the APP sensor 6P connector at terminal number 4, and the second test point is the body ground. If continuity exists, it is likely that there is a short in the VCC4 wire connecting the PCM and the APP sensor, necessitating repairs to this wiring. Conversely, if there is no continuity, then the wiring is not shorted, leading to the next step in the troubleshooting process. In step 4, you will conduct an open wire check of the VCC4 line. With the vehicle still in the off lock mode, ensure that both the APP sensor 6P connector and the PCM connector A remain disconnected from the wiring harness. This careful disconnection is essential for accurate testing. Again, measure the continuity between test points. The first test point remains the APP sensor terminal number 4, and the second test point should now be from the PCM connector A at terminal number 45. If continuity is present between these points, it indicates that the VCC4 wire is intact and functioning correctly. If continuity is absent, it could signify an open circuit within the wiring, which would need to be repaired to restore proper communication between the APP sensor and the PCM. Moving on to step 5. This troubleshooting step focuses on checking the continuity of the SG4 line. Similar to the previous steps, ensure that both the APP sensor 6P connector and the PCM connector A are disconnected. For testing, measure continuity between the two designated test points. The first remains terminal number 5 on the APP sensor 6P connector, while the second should now be taken from the PCM connector A, specifically at terminal number 46. If the continuity test passes, this confirms that the SG4 wire is functioning correctly, and there are no concerns with this particular connection. However, if continuity is not present, this may indicate an open circuit within the SG4 wiring, which would necessitate repairs to restore connectivity between the APP sensor and the PCM, ensuring the signal is appropriately communicated. In troubleshooting step 6, the focus shifts to the APS1 line. Begin by ensuring that the vehicle is turned off, lock, for safety. As in previous steps, jump the SCS line with the HDS and wait for a minute for system reset. Afterward, disconnect the PCM connector A again, allowing you to isolate the component for testing. With the APP sensor connector still disconnected, check continuity between test points, specifically at terminal number 6 of the APP sensor 6P connector and body ground. If continuity exists at this step, it suggests that there may be a short in the APS1 wire connecting the PCM and APP sensor, necessitating a repair in this wiring segment. Conversely, if continuity is absent, then the wire is not shorted, prompting you to proceed to the next troubleshooting step. Step 7 continues with the open wire check specifically for the APS1 line. Ensure that the vehicle is still in the off-lock mode for safety, with both the APP sensor 6P connector and PCM connector A disconnected. For continuity testing, measure between terminal number 6 of the APP sensor connector and terminal number 32 of the PCM connector A. If continuity exists, this indicates that the APS1 wire is undamaged and operational. However, if the test shows no continuity, this suggests there is an open circuit in the APS1 wire, necessitating a thorough examination and repair of the wiring to re-establish electrical connection between the APP sensor and the PCM. The final troubleshooting step encompasses verifying the functionality of the APP sensor itself. Begin by substituting a known good accelerator pedal module, ensuring that the replacement is compatible with the vehicle model to avoid discrepancies. After this substitution, reconnect all previously disconnected connectors securely to ensure proper electrical connection. Proceed by turning the vehicle to the on mode, and once again, utilize the HDS to clear the error code. It's essential to wait approximately 10 seconds after clearing before checking for pending or confirmed DTCs. If DTC P2121 reappears, the original APP sensor may need to be replaced. However, if the code does not return, it indicates that the APP sensor was the root cause of the initial issue, confirming that the recently substituted sensor is functioning properly. Following all troubleshooting and potential repairs made for DTC P2121, it's vital to conduct a final verification to ensure the integrity of the repair. This includes checking for the reappearance of any new DTCs that may have emerged following the repairs made. Once the system is clear of any codes, performing a test drive is essential to assess real-world operation and ensure that the vehicle accelerates smoothly with appropriate throttle response. The vehicle should be driven under normal conditions, closely observing for any signs that were previously present, such as sluggish acceleration or warning lights illuminating on the dashboard. If successful, the diagnostics confirm that the issue with the APP sensor A has been resolved, marking the conclusion of the troubleshooting process. Document all findings and repairs to maintain comprehensive vehicle service records. Preventive maintenance is crucial not just for DTC P2121, but for overall vehicle health. Regularly checking the wiring associated with the accelerator pedal position sensor is essential to detect any signs of wear, fraying, or damage before they lead to bigger issues. Additionally, inspecting connectors and terminals for corrosion or loose fittings can help safeguard against intermittent connectivity problems that could trigger a DTC. Regular cleaning of these connectors helps ensure a solid electrical connection. Scheduling periodic diagnostic tests can also play a vital role in identifying issues proactively rather than reactively, aiding in catching faults before they disrupt vehicle operation. Keeping these components in good condition helps maintain proper throttle response, optimizing vehicle performance and safety. In conclusion, Understanding the role of the APP sensor A is vital for diagnosing DTC P2121. Following systematic troubleshooting steps, ranging from verifying DTCs to checking wiring continuity, is essential in pinpointing the issue accurately. Each step builds on the previous one, helping to isolate whether the problem lies within the sensor itself, the wiring, or even the PCM. Ensuring thorough verification post-repair is equally important to confirm that the solution effectively addresses the problem and that the vehicle operates normally thereafter. Adhering to these diagnostic processes not only resolves the immediate issues, but also contributes to the vehicle's long-term reliability and performance. Keeping records of repairs and conducting preventive maintenance are key practices to mitigate future occurrences of similar codes, ensuring the vehicle remains and operates optimally. Please like and subscribe to the channel. See you next time.